We want to do this problem. A circular balloon is inflated with air flowing at a rate of 5 cubic centimeters per second. How fast is the radius increasing when the radius is at 1 centimeter, 10 centimeters, and 50 centimeters? In order to do this problem, we need to figure out the volume of a circular balloon. We're going to say this balloon is spherical because it says it's circular. So basically, we want to find the volume of a sphere. Don't overthink too much. You can always, if you forget the volume of a sphere, do what I just did and just type in volume of a sphere into a Google search or whatever search engine you're going to use. And you should find that it is 4/3 pi r to the third power. Once we have this established, then we can say, let's take the derivative of both sides with respect to time. Our time is going to be in seconds because that's what the rate of change it says is. So 4/3 multiplied times pi, those are constants. And when we come across the radius cubed, since that radius is an inside function, we're going to take the 3 out front and multiply 3r squared multiplied times the derivative of r with respect to time. I can clean this up just a little bit. Might as well do that. 4/3 times 3 is 4. So it is 4 pi r squared multiplied times the derivative of r with respect to t. This problem says that you're blowing air into the balloon, and the air that's going in is 5 cubic centimeters per second. It's going in at 5 cubic centimeters per second. That's the change in volume there. So 5 is always going to be the change in volume. And now we can find the change of rate of the radius when the radius is 1 centimeter, when the radius is 10 centimeters, and when the radius is 50 centimeters. We'll do these one at a time. Let's take when the radius is 1 centimeter. Basically, all you're going to do is plug in 1 into the radius of this equation and then solve for dr dt. When we do that, you get 5/4 pi is equal to the change in radius with respect to time. If you follow through on the labeling is going to be centimeters per second. Moodle may ask you to round this number to a certain number of decimal places, whether it's 2 or 4 decimal places or something like that. We can do the same thing with any radius. Now that you've seen that, it's pretty easy to understand what you have to do. When the radius is 10, just replace the r with the number 10. If you were to solve this, you end up with 5 divided by 400 pi. is the change in radius with respect to time. That's the rate the radius is changing. Again, the label there would still be centimeters per second. And then when the radius is 50, we just change that R to a 50. And then when you solve that, you get some pretty big numbers. You get 5 over 10,000 times pi. When you take 50 times 50 times 4, you get 10,000. And that is the rate of change of the radius with respect to time. So notice that when the balloon is at radius 1, when that sphere is pretty small, then the radius of the balloon is changing by a pretty decent large number. But as the balloon gets bigger, it's going to take longer and longer to increase that radius. So that's how these problems are done. And again, Moodle may ask you to, instead of writing this as 5 over 400 pi, Moodle may ask you to round that number to a certain number of decimal places. So 5 divided by 4 pi, instead of writing it like that, Moodle may ask you to write that as 0.3979 or something of that nature. So that's this problem.